All right. Looks like we have Algebra 2, Lecture 1018, 1019, OAS A2A14. The student will solve quadratic equations. Again, quadratic equation is an equation in which the highest power of the variable is a 2. And we're going to solve it by isolating the variable just like we did in pre-algebra. We're going to isolate the variable and then take the square root of both sides of the equation, and then remember to include positive and negative solutions. I'll show you how that works. So here we are, we're solving quadratic equations, and the first thing we want to do is isolate the variable. In pre-algebra, we would undo addition with subtraction, we would undo multiplication with division, so forth and so on, as we remember. Here we've got x squared, and we want to undo, so to speak. We want to get rid of this squared, and the way that we do that is to take the square root. The addition undoes subtraction, multiplication undoes division, so to speak, and square roots undo squares. So what I'm going to do to isolate this variable to get rid of this square is just to take the square root of both sides. Now when I do that, I've got to stop and think. X equals, well, what's the square root of 100? We all know that that's 10. Right? Because 10 times 10 is 100. And so that means if I plug in a 10 right here, I can square 10, 10 squared is 100. But if we stop and think for just a second and give a little bit of analysis, we'll realize that there's also another value we can put in here. If we put in a negative 10 here, negative 10 squared, remember those parentheses are absolutely necessary, negative 10 squared is also 100. So 10 is not the only solution of this equation. If positive 10 will make it work, and so will negative 10. So we generally write our equations when we take the square root of both sides of an equation, we write our solution plus or minus whatever the square root of our constant is. So in this case it would be x equals plus or minus 10. There are two solutions. If you were looking for the solutions as a set, they might look like this. And sometimes you'll see the set written as both of them. And sometimes you'll just see it written like this. All three of these are appropriate ways of stating the solution to this particular equation, x squared is equal to 100. I look at this one, we've got r squared is equal to 23. Well, I'm going to do the exact same thing I just did by getting rid of this squared. I'm going to get rid of the square, I'm going to take the square root of both sides. This will give me r equals the square root of 23. There is no value, no number that's not a big long decimal that never ends and never repeats. Value of the square root of 23, it's not a perfect square, so I'm just going to leave it under the radical. That means if I plug in the square root of 23 right here and I square it, I'll get 23. But just as we had a positive and a negative solution here, we also have a positive and negative solution here. So our solution here is positive or negative radical 23. If I square either one of these, positive radical 23, if I square it, I'll get 23. If I square negative radical 23, I'll also get 23. So here are our solutions. You could see them written like this or expect to see them written like this. Doesn't matter which one comes first. Or you could see them written like this. Again, three ways of writing the solutions to this original equation right here. If I plug in positive radical 23 here and square it, I'll get 23. If I plug in negative radical 23 here and square it, I'll get 23. Well, there we go. Let's take a look at another one. Here we want to isolate the variable. There are two things I need to get rid of. I need to get rid of a multiplied negative 6. I'm going to divide both sides by negative 6. And then I want to get rid of that square. So here we go. I'm going to divide both sides by negative 6, just like we did in pre-algebra. This will give me p squared is equal to whatever 386 divided by 4 is. Negative divided by negative is positive. This will give me 4, I believe. Positive 64. Let me check it with my calculator because it's early in the morning and my brain doesn't always work well. 384 divided by 6. 64, yay! And negative divided by negative is positive. Now I'm going to take the square root of both sides. And this will give me P is equal to, the square root of 64 is 8, so it'll be plus or minus 8. Positive or negative 8 are the values I can plug into this original equation and get negative 384. If I plug in a positive 8, I'll get it. If I plug in a negative 8, because negative 8 times negative 8 is 64, 64 times negative 6 is 384, negative. So there we go. We isolate the variable, and if we don't make any arithmetic mistakes, we'll be looking at our solution. And again, you could write the solution like this, or look for it like this. You could expect to see it looking like this in a multiple choice, or like this. These solutions could be written, to this equation could be written like this, this, or this. You could expect to see them in a standardized test, written in any of these three ways. Here we go. I'm going to do the same thing I just did in this one. I'm going to isolate my b. First thing I'm going to do is add 4 to both sides. Then I'm going to take the square root of both sides. That's the plan. Here we go. Adding 4 to both sides. B squared is equal to, what is that, 99? I take the square root of both sides. If I take the square root of 99 with a calculator, I'll get 3 radical 11, I believe. Let me make sure I did that in my head. Oh, let's see. Second function, square root 99, enter. 3 radical 11, yay, I'm gonna roll. And because I've taken the square root of both sides of an equation, within the context of the equation, we have to consider both possible roots, plus and minus. So there are our solutions right there, and we can see them written like this. We can see them written like this, or like this, or like this in a standardized test. Okay, any of these three will suffice. Added 4 to both sides, took the square root of both sides. Square root of 99 is 3 radical 11. We included both positive and negative possibilities. There we are. Let's take a look at another one, if we have any more. Hey, we got a couple more. So again, we're going to solve this for r squared just like we would in pre-algebra. I'm going to add 10 to both sides and then divide both sides by 9. That's my plan. Once I get r squared isolated, I'm going to take the square root of both sides and remember to include positive and negative solutions. So I'm going to add 10 to both sides. This will give me 9r squared is equal to, what is that, 144? I'm going to divide both sides by 9. R squared is equal to 144 over 9. Now I want to get rid of the squared, so I'm going to take the square root of both sides. This will give me r. The square root undoes the square, so to speak. And this will give me, I'm going to say plus or minus, because I know it's going to have a positive and a negative solution, or a root. And this will give me 12 over 3. Square root of 144 is 12. Square root of 9 is 3. And 12 divided by 3 is 4. So we could say the set whose members are 4 and negative 4. We could say r equals plus or minus 4, or we could say the set whose members are plus or minus 4. We could expect to see it written in any of those three ways in a standardized test. Okay, and let me check my answers. I got the key around here somewhere to make sure I'm getting them right. Might as well check them all. Plus or minus 10, plus or minus radical 23, plus or minus 8, plus or minus 3 radical 11, yay. And plus or minus 4, yay. So far I haven't made any mistakes. That's good. I'm on a roll. Here we go, last example of how we're going to do this. I'm going to try to get r squared by itself. I'm going to subtract 3 from both sides, then divide by 10. That will isolate r squared. Once r squared is isolated, I'll take the square root of both sides, and remember to include positive and negative roots or solutions. Here we go, subtracting 3 from both sides. 10r squared is equal to 920. Dividing both sides by 10, r squared is equal to 92. Taking the square root of both sides will give me r is equal to plus or minus, it's 2 times 46, which is 2 times, so there's a perfect square in there. That'll be 2 radical something or another. My brain just went blank, so I'll do it with my handy dandy pocket brain. Pardon me. The second function, square root 92, 2 radical 23. And those are the values, the 2 values I can plug in right here. I can plug in 2 radical 23 here, square it, multiply by 10 and add 3, and I'll get 923, or negative 2 radical 23, square that, make sure it's in parentheses, then multiply by 10 and add 3, and I'll get 923. And again, if you're taking a standardized test, you can expect to see the answers written like this, or like this. And remember, the order of the elements of the set doesn't matter. The negative one can come first. Any of these 3 is an appropriate way to state the solutions to this original equation. There we are. Solving quadratic equations, if there's only an r squared term, there's not an r term, there's not a linear term. We just isolate it just like we did in pre-algebra, and remember to include positive and negative roots or solutions. And that was our objective. You can do this.